The other tool we want to take a look at is VisualVM. This is installed along with the JDK as part of the standard download. And you can launch it from a command line just by typing JVisualVM. It's also available as a standalone tool. And if you go to visualvm.java.net, you can download it and run it from here. To run VisualVM, we can go to a command prompt, type JVisualVM, and it'll run up. And the tool gives us access to various monitoring tools for a Java application. So for example, if I go and click on the IntelliJ platform here, so we're running IntelliJ IDEA at the moment. From inside here, we get an overview of the application. We click on Monitor, and we can see some of the monitoring information. We click on Threads, and it gives us again threading information. We can do profiling. There's a sampler, and we can run a profiler. Notice that from the monitor, we do have access to the GC. So if I uncheck CPU and classes and threads, then we do get some information about the garbage collection behavior, but we don't get much information here. To display more information, we need to install VisualGC. So this comes as a plugin for VisualVM, and as we'll see in a moment, gives us much more information about what's happening inside the virtual machine with regards to garbage collection. So we've seen running VisualVM. To install a plugin, we go to Tools, Plugins. One of these is VisualGC. If I select that and click on Install and go through the wizard, then that plugin is now installed. If I close down the app here, the view of the app, and reopen it again, we now see VisualGC on the tab, and we'll see we get lots more information about the garbage collection that's happening. So if we go back to the application we saw previously, I made one slight change here. I've just added a thread.sleep call. The reason I've done this is it will enable us to see more easily what's happening inside VisualGC when we run the application. So from the command prompt, if I run the application, we notice this is going to run a lot more slowly now because of that thread.sleep call. If I go into VisualGC, there's the application. And if I double click on this, we load up the details. Go to the VisualGC tab, move this out of the way. And what we can see here is allocation as it's happening. So we can see that there's memory in the S1 survivor space. We can see the Eden space filling up, the memory being allocated. Then as the Eden space is full and the garbage collector runs, we've seen the survivor spaces flip over, so the memory is now allocated inside the S0 survivor space. And if we leave this run a little longer, again we'll see the Eden space fill, our garbage collection happen, and the S1 and SO spaces flip again. Notice that we are generating memory inside the old generation here, so the old generation is accumulating memory. But at the moment, it's accumulating very slowly. And at the moment, there have been no GCs inside the old generation. And we've just seen a single GC has now happened inside the old generation. So again, with this application running relatively slowly and allocating relatively infrequently, we see GCs happening less frequently. The information at the bottom, the histogram, is showing information about the objects that are in the survivor spaces. So this is trying to show what's called a tenuring threshold. The number of objects that have survived garbage collects. So the histogram shows the number of objects that have a garbage collection survival kind of 1, 2, 3, 4, 5, and then what happens to those objects as more and more garbage collections happen. A better example of that is for IntelliJ IDEA. So here, we get more information. We can see we have objects that have survived a single garbage collect, 2 garbage collects, 3 garbage collections, so on and so forth. We'll find that the Java virtual machine will modify its behavior depending on the behavior of your application. It will try and predict as best it can your application's behavior based on previous behavior. And then based on that, try and organize the garbage collection algorithms as best it can. So how high to set the tenuring threshold, how often to run garbage collections, how much memory should be allocated to Eden space and the survivor spaces, how much memory should be allocated to the old spaces. So if I go back to our application and kill it, go back into IDEA and take out the thread.sleep call and build the application again, and then go back and run the application, and go back into VisualVM, close the old window, go to the applications and reopen the window. We'll now see very different behavior inside VisualGC. So we're now allocating memory very, very quickly. So we can see the Eden space is filling much more quickly. There are going to be more old generation garbage collections. At the moment we're up to 57, 58, 59, so that's counting very, very quickly. Also the number of collections in Eden space is rising very, very quickly as well. If I kill the application again and run it with a G1 garbage collector, go back into VisualGC, go to the Applications tab, look at the application again, look at the VisualGC tab. Again, we're seeing different behavior. So again, we're seeing the Eden space memory rise, we're seeing old memory rise and fall, we're seeing the survivor space memory being allocated, we've seen the number of objects that are with a tenoring threshold of 1, and when they get moved around, we're occasionally seeing objects with a tenoring count of 2, and those being allocated and freed. Notice the behavior here is very, very different to the behavior that we saw with the default and standard garbage collector, the serial garbage collector. So what are we actually seeing here? Well, we're seeing 3 different areas within the application. One showing the spaces, one showing the memory allocation and some other information that's going on, and then one showing these things, this histogram, showing some of the thresholds to do with when objects are moved from space to space. If we simplify this slightly and take a look first of all at these spaces. So here we can see the memory allocation as it's happening, and we see that in the Eden space the memory is slowly rising. So the amount of memory allocated there is slowly rising. And currently the S0 space, so the S0 survivor space, is full. What we'll see is as the memory Eden space increases and finally hits its threshold, then the garbage collector will run, the GC will happen, S0 will become empty, S1 will become full, and the Eden space will go back to 0. And that happens now. And notice as well at the same time, we've allocated a lot more objects into the old space. So the old space is nearing its threshold. And the next time we run a GC in the young space, when the Eden space is full again, we should see the old space being garbage collected as well. So what else do we see? So if we take a look at the histograms, these are showing us the objects that have survived a garbage collect and the number of garbage collections they survive. So in this case, because the garbage collector is self-modifying, we only have objects that have survived a single garbage collection before they've been moved off into old space. And then finally, the graphs themselves. So this shows the ongoing graph of memory allocation inside the VM. And we can see here where the garbage collector has run and reduced the memory in Eden space almost to 0. Memory then being allocated further and further into Eden space. And eventually Eden space will fill. And when it does fill, we'll see the garbage collector running again, reducing its space to 0. And we'll see the survivor spaces flipping over. So there we go, the garbage collector's run, survivor spaces are flipped. Notice as well there's a kink there inside the old generation. This is where the memory that survived these garbage collects has been moved out into old generation. So the amount of memory inside the old generation has also increased. And eventually one of 2 things will happen with the old generation. When another garbage collection happens, if we haven't reached the maximum size of the old generation, we'll allocate more memory in there and we'll move objects into there. If we have reached the maximum size of the old generation, then the old GC garbage collector will run.